Hi, I'm Francesca. Today, I will demonstrate to you a phenomenon related to James Prescott Joule's mechanical equivalent of heat. This is the conversion of mechanical energy into heat energy. Scientists in Joule's time believed that a fluid-like material called caloric was responsible for making objects warm or cold. When objects absorbed caloric, they would become warmer, and when they lost caloric, they would become colder. According to this theory, an object could become warmer only if they came into contact with a warmer object, so that caloric would flow from the warmer object into the cooler object. On the contrary, Joule believed that objects could become warmer without coming into contact with warmer objects, because he is convinced that all forms of energy are the same, and that one form can be changed into another. Therefore, he believed that mechanical energy could be transformed into thermal energy. Now, have you ever wondered if you can get heat from a blender? So today, I'm going to show you that you can blend water and increase its temperature. It is not necessarily as effective as heating it on a stove, but you can still do it and see the results. Let's try it. So what we're going to do is we're going to take this blender, which gets its energy from the wall outlet. Then it converts it into mechanical energy inside the blender and the spinning blade, and that energy will be transferred to the water in the form of heat. The way that Joule did his experiment was he took a container of water with weights suspended by pulleys, and he would drop them. Now, the work done by those weights due to gravity was the work that was transferred to the water, and that's how he measured heat transfer. His experiment was incredibly insulated. He got it down to very precise numbers, which was 772.55. Interesting fact, this number is inscribed on his tombstone, but now the specific heat capacity of water is known as 4.18 times 10 to the third joules per kilogram degrees Celsius. This blender may not be as insulated as his system was, but it would still make a pretty good demonstration. So now what we're going to do is perform the experiment. We will measure the initial temperature of the water, and it's 80.8 degrees Celsius. This is an infrared thermometer, which uses infrared light to measure the temperature. Now that I've measured the water's initial temperature, I'm going to blend it for 120 seconds and time it to try to keep a consistent amount of time between blending. After 120 seconds, I'm going to measure the water's temperature. Now, I observed an increase of 80.8 to 98.8 degrees Celsius. I'm going to do it again so I can compare the change in temperature better. Now, the temperature went from 89.8 to 98.8 degrees Celsius. That means for every 120 seconds that we blended, the temperature increases by 9 degrees Celsius. The temperature of the water rises as the blender runs. This phenomenon was done by the blender's blade moving very quickly through the water. The electrical energy transferred to the blender when it was turned on was transferred into mechanical energy by the blender's motor, shown by the blade spinning. Since there is friction between the blade and the water, some of its mechanical energy was transformed into thermal energy. Hence, the water becomes warmer. Now, I will show the quantity of heat required to raise the temperature of 250 milliliters or 0.25 kilograms of water from 80.8 to 98.8 degrees Celsius. Since 250 milliliters of water is heated from 80.8 to 98.8 degrees Celsius, we want to know how much heat is absorbed by water. Step 1. Since the quantity of heat equation is based on the mass of an object, we must first determine the mass in kilograms of 250 milliliters of water. To do this, we will use the density of water, which is 1.0 grams per milliliter. Next is step 2. We can calculate the change in temperature of the water by using this equation. The change in temperature is equal to T2 minus T1. T2 is the final temperature and T1 is the initial temperature. Last is step 3. Now that we have calculated the mass of the water in kilograms and the change in temperature, we can use these values to calculate the quantity of heat, which is 1.88 times 10 to the 4th joules. So the water absorbs 1.88 times 10 to the 4th joules. Therefore, the quantity of heat required to raise the temperature of 0.25 kilograms of water from 80.8 to 98.8 degrees Celsius is 1.88 times 10 to the 4th joules. Note that if an object absorbs energy, its final temperature is greater than its initial temperature, and the value of the change in temperature is positive. However, if an object releases thermal energy, its final temperature is lower than its initial temperature, and the value of the change in temperature is negative.